One of the most important power grids in the entire United States is staring down a massive power shortage, and it's all because of the tech boom. Now, the official solution? It involves spending billions and billions of dollars. But what if that whole plan is aimed at the wrong problem?
So to really wrap our heads around what's at stake here, we have to understand the sheer scale of this crisis. I mean, this isn't just some small glitch in the system. We're talking about a fundamental gap between the power we have and the power we desperately need.
It all kicks off with this one number. PJM, that's the grid operator for 13 states plus DC, recently put out a warning. They're predicting an 8.7 gigawatt capacity shortfall. I mean, that sounds huge, right? But what does a number like that actually mean in the real world?
Well, to put it in perspective, that abstract number translates to a power gap big enough to supply almost 7 million homes. It's just a staggering figure, and it's not some distant future problem. It's looming just a few years away.
So where is all this demand coming from? Well, it's really a perfect storm. On one side, you've got this insatiable appetite for energy from new data centers, the engines powering our digital world. And at the exact same time, old coal plants are retiring, taking these huge chunks of power generation offline for good.
Okay, so with a problem that big, you'd think there has to be a big plan to fix it, right? I mean, the people in charge see this coming. So what's the big idea? How are they going to handle this? It's called the Reliability Backstop Auction. And really, the plan is to throw billions of dollars at the problem. They want to fast-track approvals for new power plants and use emergency measures to get them built. In short, it's a massive push to just build more supply.
And look, on the surface, that sounds logical. Not enough power? Build more power plants. Simple. But there's this huge, fundamental flaw in that thinking. A critical piece of the puzzle that this entire multi-billion-dollar plan just completely ignores.
This is where we get to the real bottleneck in the system. And let me tell you, it is not what you might think. So here's the core of the whole misunderstanding. The backstop auction, it assumes the problem is a lack of money. But tech companies, developers, they've got deep pockets. The real problem is physical. It's a massive, years-long queue, a traffic jam, just to get new projects connected to the power grid.
And that brings us to a really simple but incredibly powerful truth. It doesn't matter how much money you have or how fast your permits get approved if you can't physically plug your brand new power plant into the system.
And this is the frustrating reality for developers today. A project full of promise enters that connection queue, and then it just sits there for 4 years, sometimes more. And when it finally gets a response, it's a massive bill for grid upgrade costs. So often, the project just isn't viable anymore, and it gets canceled. And believe me, this isn't a rare thing. Even among PJM's hand-picked, so-called shovel-ready projects, about a third of them, end up dropping out. A 1 in 3 failure rate for your best prospects, that tells you the system itself is the problem. So, if just building our way out of this crisis isn't working, what's the alternative? Well, this is where we have to make a major shift in our thinking, a completely new way of looking at the grid. You see, for decades, grid planning was built on one big rule. Every single power source had to be strong enough and connected well enough to deliver power to the entire region. And, that made sense in a world of slow, widespread growth. But that's just not our world anymore. Today's demand is super concentrated. We're not trying to power a whole region. We're trying to power one single massive data center that's in a very specific spot. The old rules are just total overkill. And this leads to a fascinating question. What if we're so focused on building these giant centralized power plants that we're missing other, way more effective resources that are already sitting right in front of us? Right now, the auction only sees one thing, megawatts. But it's completely blind to a huge range of other valuable assets, things like water compliance funds, emissions permits, even community agreements. These are real, tangible resources that are completely invisible to the current planning process. And that brings us to the big paradigm shift. The solution isn't another piece of hardware like a power plant. It's a new piece of software, a coordination mechanism that can intelligently use all these existing, unseen resources that are already out there. All right, so let's look at the final piece of this puzzle. This is a way of thinking that moves completely beyond the limits of the current just build more approach. The author of our source material calls this missing layer geometry. And honestly, that's a perfect way to put it. Think of it this way. The auction sees a simple list of power suppliers, but it doesn't see the map.
It has no idea about the physical distance and the relationships between a data center's needs, a nearby generator, and available local resources. It's missing the spatial intelligence to see the whole picture.
And the payoff for seeing this geometry is huge. By carefully coordinating projects, like say putting a battery storage facility in just the right spot near a data center, you could bring power online years faster. Why? Simply because you could avoid the gridlock of those massive, slow-moving transmission upgrades.
As Tom Ritigliano from the NRDC puts it, the old way of doing things just can't keep up. The data center boom is a whole new kind of challenge, and it demands a new kind of solution. We simply cannot use a 20th century playbook for a 21st century problem.
So this leaves us with the essential question, doesn't it? As we face this unprecedented demand for energy, is the answer really just to spend billions building more of the same? Or is it to get smarter, to see the whole picture, and to coordinate the powerful resources we already have? The future of our grid may very well depend on the answer.